Hello and welcome. In this tutorial, we are going to solve problem number 32 of Leetcode, that is search in a rotated sorted array. So we have given an array nums which is sorted in ascending order, and it has been rotated at a pivot point k, something you can see that if we rotate this sorted array at pivot point index 3, that means 0 1 2 3. After rotating it from index 3, it will become 4 5 6 7 at beginning, and 0 1 2 is appended at last. So we can say that our rotated array will be something like this. So we have given two input in this example. So 4 5 6 7 0 1 2 is input, and we have to find the target 0. So if we found the target, then in that case we have to return the index of that target, and if we are not able to find the target, that we have to return -1 in that case. Okay, so let's first understand this rotated and sorted array. So let's say we have a sorted array something like 0 1 2 4 5 6 7. If we rotate it from index from one position, it will be something like 1 2 4 5 6 7 and 0. Again, if you rotate it by one time, it will become something like 2 4 5 6 7 0 1. And if we keep rotating it, and then it will be at a point we found that our rotated area will be something like this: 4 5 6 7 and 0 1 2. So this is the sorted array, and after rotating this will become rotated sorted array. Okay, so we can see that our rotated sorted array can be divided into two sub array like 4 5 6 7 and 0 1 2. Okay, so we can say these two sub arrays are already sorted in already in sorted form. So we can say that we have to find the array in any of these two. So how we can find the our target from this rotated sorted array? So one way is to use linear search. How we can apply linear search? We have to keep iterating from index 0 to index n minus 1, and we have to keep checking that whether our current value is equal to target. So whenever we found that our current value is equal to target, we have to return the index from there, and we will be able to find our element. So in case if we are not able to find the element after iterating all the indexes, then we can say that there is no such element present in array. So in that case, we have to return -1. Okay, so this is the approach that we have to follow in linear search, but you can see that we have to iterate throughout all the array. This is going to take big of n time, and you can try this approach also, but this is not the advisable, and we have to come up with some other approach which can be something like binary search. So how we can apply binary search in this problem? So till now we know that binary search can be applied if our array is sorted, but you know that this array is not completely sorted, it is rotated sorted. So how we can apply binary search in this? So what does binary search means? Binary search means in every iteration we have to eliminate the half part of array. So if somehow we will be able to eliminate the half part of array in every iteration, then we can say that we can apply this binary search. So let's go to the next slide and try to understand this, how we can apply binary search. So we have given array 4 5 6 7 0 1 2, and target equal to 0. So what we do in binary search, we assign a left index, that is 0, and right index, that is in this case 6, and we have to find out the mid. So this is the left, this is the right. Okay, and if we found out the mid, then mid is going to be left plus right 2 by 2, that means 0 plus 6 by 2, that means 3 in this case. So this is our mid. So first we have to check that our mid is equal to target. If we found out that, let's say, our mid was not 3, in this case in we have given some more element, and our mid was something like 4. So we found our mid at first per time, then we have to return from there. So first we have to check whether our current mid is equal to target or not. So we can see that our mid is not equal to target. In that case, we have to go to if L, we have to go to the else part. So what are the conditions that we have to check in else part? So one condition can be something like, first write the else, if will be nums of mid is found to be equal to target, in that return mid. Okay, in else if part we have to check some condition. So what will be that condition? We have to check whether nums of left is lesser than or equal to target. So if we found that our nums dot left is lesser than equal to target, that means we can say that we are in our left part is sorted. So if we found that our nums dot left is lesser than target, let's say our mid was something like 1. So in that case, or we can see that our nums of left is not lesser than our target. So we can see that in that case we are in rotated sorted array. So first we have to check that whether we can eliminate half of the part. So we have to check if else if nums of left is lesser than equal to nums of mid. So if this is true, then we have to do something in this part, and there will be a else part which will be if this is not true. So we have to do something in that part. So what we have to do, if we found that our nums of left is lesser than target, we have to check whether in this part our target is present or not. So for that we have to check if nums left is lesser than target. If we found that nums left, how we can say that our target is present in this part? Let's say our target was something like 5. So we have, then we then we have to ensure that our target is present in this left part. So how we can ensure that? If our nums of left is lesser than target and nums of mid is greater than target. So if let's say 4, we have to check out 4. So how we can ensure that 4 is present in left part? For that we have to check that nums of left is lesser than and as well as equal to target. So we have to check if nums of left is lesser than and equal to target, and as it is, nums of right mid is greater than target. So if this condition is true, then we can say that our target is somewhere in between this left part. So we don't have to search this remaining right part, we can eliminate this part. So this is the way we can eliminate the half part in this is rotated sorted array. Okay, so in if this condition is true, then that means we can say that our target will be somewhere in the left part, so we can go towards left. So for that we have to do tar right equal to mid minus 1, and then we eliminated this right part. Okay, and if this condition is not true, that means our target is not present in our left part. So in that case we have to go right toward right. So how we can go right? We can go right by doing left equal to mid plus 1. Okay, so for this left will become this mid plus 1, and right is, as you can see, that 6. So this was the condition that we have to check if we found that our nums of left is lesser than or equal to mid. That means this is the sorted part. What if let's go for the second condition. So let's just clean up this and write the condition again. So we had 4 5 6 7 0 1 2. Okay, so after this, let's say we have a we are in else part. So how we can come in else part? If we found that, let's say our mid is this, so we can see that our nums of left is not lesser than equal to nums of mid. So in this case we will come at else part. So in this we have to again check some condition, how we can ensure that our element is present in this right part only. So for that we have to do first check whether nums of mid is lesser than target or not. So and nums of mid is lesser than target, we can see that nums of mid is not lesser than target. And again, let's say our target was 2, target was 2 in this case. So what we have to do? We have to do nums of, first we have to check if nums of left is lesser than target and nums of right is greater than or equal to target. So if this condition is true, that means we can say that our target is somewhere in this right part. So we have to check first nums of left is lesser than target and nums of right is greater than equal to target. So if this condition is true, we can say that our target is present somewhere in the right part. So in this case we have to go towards right. How we can go towards right? We have to do left equal to mid plus 1, and there will be a else part where we have to go toward left when this condition will be true. When we say that this condition is not true, that means our element is not present in right part, then we have to only check towards right left part, then we have to go right towards right, so towards left, so we have to do right equal to mid minus 1. Okay, and this is the algorithm that we have to follow. Let's do a dry run and try to find the answer for this condition. So again, let's clean up and write the condition again. So we had 4 5 6 7 0 1 2, and this is the left and this is the right at beginning. And first we will find the mid is going to be 0 plus 6 by 2, that means 3. This is going to be our mid. Okay, so first we'll check if nums of left is lesser than equal to nums of mid. So yes, this is true. So first we'll check if current element is equal to target. So this is not current equal to target. So we will come else if part, and we can say that this is true. So this else if part will be executed, and inside this we have to check if nums of left, that is this, is lesser than equal to target. Yes, no, this is not lesser than equal to target, as our target is 0, and so we'll not checking this end part and remaining condition, and we will come to the left. So we have to go towards left. So our left will be updated from 0 to from 4 to 0, that is index number 4, and we will delete this left and this mid. We have to again find the mid. How we can find the mid? We can find the mid using these two indexes, 4 plus 6. So 4 plus 6 divided by 2, that means 5 is going to be our mid. So this is going to be our mid. And again we will check if nums of left is lesser than equal to nums of mid. You can see that nums of left is lesser than equal to nums of mid. So we'll come again in this part, and we'll check if nums of left is lesser than target. Nums of left is lesser than target or equal to target. So we can say the nums of left is lesser than target and equal to target. So this condition is true. And we have to again check if nums of left mid is greater than target. So we can say the nums of mid is again greater than target. So this condition is getting true in this case. And what we have to do? We have to go towards right side for this. So our mid will be, or sorry, our left will be mid minus 1, that is our left. Our right will be mid minus 1, so right is going to be mid minus 1, that is this. Now again left and right both are equal to index 4, so this will be eliminated. And now we have to find the mid is going to be 4 plus 4 by 2, that means 4. And now we are nums of mid is going to be target, so we have found our index and we have to return that mid, that is going to be 4 in this case. Okay, so we found our element in this case. And now I hope you must got an idea how to solve this problem. Now go to the compiler and write the code for same. Okay, so we are going to need left and right. So first assign that left is going to be 0 and right is going to be nums dot length minus 1 at beginning. Okay, we have to run a while loop until unless our left is lesser than equal to right. So this is the template of any binary search. So first we have to find the mid is going to be left plus right by 2. So we'll find the mid. Left, this is going to be left plus right minus left divided by 2. So for that we can do this. Okay, so using this we'll be able to find our mid, and first we have to check if our mid element is equal to target. So in that case first check if nums of mid equal to target. If this is true, then we have to only return the mid element, mid index. Okay, and this is not true, then there will be two condition. So first condition will be something like this, that we have to write, and then there will be a else part. So first add the first condition, that means first check whether left part is sorted. If it is sorted, then we have to check in that part, and if we found that this is not sorted, then we will come to else part. So for that we have to check that nums of left is lesser than equal to nums of mid. Okay, and inside this there will be several conditions. If first condition will be that whether our target is present in this part or not. If this our target is present in that part, then we have to search in that part only, and if it is not present in that left part, then we have to go towards right. So first for that we will be checking if nums left is lesser than equal to target and nums of mid is greater than target. In this case we have to go towards right. So how you can go towards right? We have to shift right equal to, so right equal to mid minus 1 in this case. Okay, and if this condition is not true, then we have to do, if this is true, that means our element is present in that left part. So in this case we have to go towards left. So for going left we have to shift the right index by mid minus 1, and if this is not true, that means our element is not present in that subarray or the left subarray. So we have to go towards right. For going towards right, we have to do right, we have to left equal to mid plus 1. Okay, and this is the condition first. If we found that our left sub array is sorted, and if this is not true, that means we have to go toward for the else part. So in else part we have to check air if element is present in the right sub array or not. So that means if nums of right is, so nums of first we have to check nums of mid is lesser than target, and nums of right is greater than equal to target. If this is true, that means our target is present in between these two mid and right indexes. So we have to search in these two, between these two indexes, that is mid and right. So for that we have to go towards right. How we can go towards right? We have already seen. We have to do left equal to mid plus 1. And if this is not true, then we have to go in else part, and where we have to go towards left. So how we can go towards left? We have to do right equal to mid minus 1. So if this whole while loop will be run iterated, and if we found the element, we have to return the index. If we not able to find, then in that case what we have to return? We have to return minus 1. So returning minus 1. After that, now we have written our binary search algorithm, and now it's time to run this. Yeah, so our solution has been accepted for all given 3 test cases. Now it's time to submit this and check whether our solution is true or not, correct or not. Yeah, so our solution has been accepted, and this is one of the most optimized approach that we can come up with. And I hope you must have learned something from this video. In that case, please make sure to like the video, subscribe to the channel, and don't forget to share this video among your friends. Thank you.